electroplating has been part of manufacturing since the dawn of the industrial age, preventing corrosion, applying hard surfaces, repairing damage, and protecting against harsh environments. Without electroplating, many modern products and conveniences couldn't exist. New chemicals and better equipment have led to incremental improvements, but the basic technology of electroplating has not evolved. You place a part in a metal solution and apply electricity through a conductor called an anode, which causes the metal in the bath to adhere. It is a massively inefficient process, burning through enormous amounts of power and taking hours or days to produce even a single plated part. It also generates mountains of toxic waste, from the cyanides of silver and gold plating to the brilliant orange hexavalent chromium, a chemical so deadly that even the tiniest spill would be catastrophically destructive to the environment. Particularly relevant from a waste standpoint is used maskant, the tape, wax, glue, and other protective coverings that shield areas that you don't want plated. After soaking in these toxic plating baths for so long, all maskant is hazardous waste.
Masking used to take hours and hours. It was subjective from one person to the other. There's a lot of operator error. Different interpretations of dimensions could result in variances that were unacceptable.
Masking is also tedious, labor-intensive, error-prone, and hard to do correctly. Plus, once the plating is done, all that maskant has to come off quickly without damaging the base. Parts must be unmasked and rushed into an oven to cook out hydrogen that seeps into the metal during the plating process. In some cases, parts have less than 2 hours to get into the oven, or they run the risk of hydrogen embrittlement, a phenomenon that terrifies manufacturers of high-strength parts. It is the source of metal fatigue damage, capable of cracking or shattering even the strongest steels. But we need this technology. Electroplating is here to stay. And the National Center for Manufacturing Sciences, along with a collaborative research team, is determined to bring it into the 21st century. The result of a several years-long research project is no-mask conforming anodes, a revolutionary plating approach that improves speed and efficiency, reduces the specter of hydrogen embrittlement, and all but eliminates toxic waste.
The housing encases the electroplating process. It creates kind of a mini plating cell. All the plating activity takes place within that area. The rest of the part is not electrically communicating with that anode, and therefore it doesn't need to be masked. And that's how the tooling gets its name.
Since the no-mask fixture is air and liquid tight, it's possible to plate parts without submerging them in a tank. Plating solution is simply pumped through the fixture at high speed, and current is applied to the conforming anode. The motion of the fluid reduces hydrogen bubbling and ensures optimal contact with the areas to be plated.
Out-of-tank plating is when you actually or physically have the part sitting on the tank or adjacent to the tank versus being inside where actually it allows us to plate adjacent to the tank. We just pump the solution out and it pumps it back in. We're not taking up any tank room. We're not taking up any additional rectifier space.
Even when used in a more traditional in-tank process, no-mask plating fixtures are hugely beneficial. The most obvious benefit is speed. With no mask, there are only a few customized pieces that just snap onto the part. Once secured, it is ready for plating. No slow masking, no rushed unmasking. And thanks to the custom-formed anode, no-mask plating is much faster and more efficient as well.
You have more efficient plating. You can get the part plated faster, sooner. The rule of thumb that we discovered in using the no-mask fixturing was that basically the plating tank dwell time is reduced by about 50%, sometimes even more than that.
No-mask frees platers from the agonizing tedium of manual tape and wax masking. Ideal anode positioning allows for much higher plating uniformity, reducing rework, grinding, and finishing, and all but eliminating reject parts. This is a zero-waste system. The tooling is simply cleaned and set aside for its next job. Quite an improvement over mountains of poison-soaked masking material. Defense Department maintenance depots have some of the toughest conditions when it comes to electroplating. In many cases, these depots deal with hundreds or thousands of different parts and face the need to get equipment back into the field as quickly as possible. Until the arrival of NoMask, efficiency was sacrificed for speed, and even then, no part of the process was really fast. All of that changes with NoMask.
What we have is a project to look at using NoMask technology for nickel plating, and particularly on a difficult part that has not had a repair procedure established for it. And this is a part that is in great demand due to our war efforts.
In order to save a part, we need to basically build that base metal back up. If it's well adhered, it acts as an excellent replacement of base material that's been missing through corrosion or other anomalies.
In the old days, they would have to go to the OEM and purchase new. There's no refurbishment on it. No repair, no refurbishment, no recycling. So now we can do that. And I don't know the approximate cost of the part, but suffice to say, because it's aviation, it's going to be big bucks.
If the 2 pilot parts used in the NoMask tooling research project saved the Defense Department $900,000 a year, imagine how much would be saved if every part used NoMask. There is no official count of exactly how many electroplated parts the Defense Department deals with, but the number is easily in the tens of thousands. NCMS and its partners estimate savings of $50 million over the next 3 years alone across the DoD. For nearly 100 years, electroplating has remained the same. Now we have revolutionized it. Higher throughput, zero waste, optimal efficiency, and immense annual savings are the promise of NoMask tooling. And as the team works on into a new phase of research, we're confident that we can bring this exciting technology into widespread use. Without electroplating, much of what we do every day, many of the products and tools on which we depend could not exist. And when you stop to consider the life-saving maintenance work our military depots perform, and the need to get equipment and platforms back to our men and women in the field quickly, there's just no alternative to superior technology.